عندي خبر علمي لسه نازل جديد. لأول مرة في التاريخ تعتبر يعني طفرة في عالم الهندسة الوراثية، إن العلماء قدروا يعملوا جينوم كامل من الألف للياء. قدروا إن هم يصمموا ويصنعوا جينوم كامل من الألف للياء، وإن هم يجمعوه، وبعد كده جابوا خلية من البكتيريا، شالوا منها الدي ان ايه بتاعها وحطوا فيها الدي ان ايه اللي هم صمموه. فبالتالي البكتيريا الجديدة دي بقت نوع تاني، أول مرة يكون موجود في التاريخ، والأول مرة الكائن الجديد ده عرف إن هو يتكاثر ويعيش عادي يعني. فتعتبر طفرة في عالم الهندسة الوراثية وليها فوائد كتيرة جدا طبعا.
We're here today to announce the first synthetic cell, a cell made by starting with the digital code in the computer, building the chromosome from 4 bottles of chemicals, assembling that chromosome in yeast, transplanting it into a recipient bacterial cell, and transforming that cell into a new bacterial species. So this is the first self-replicating species that we've had on the planet whose parent is a computer. So there were several steps to this. There were 2 sides. We had to solve the chemistry for making large DNA molecules, and we had to solve the biological side of how, if we had this new chemical entity, how would we boot it up, activate it in a recipient cell. So it's been a long route to get here, 15 years from the beginning. We felt one of the tenets of this field was to make absolutely certain we could distinguish synthetic DNA from natural DNA. So early on we developed the notion of putting in watermarks in the DNA to absolutely make clear that the DNA was synthetic. So the team actually developed a new code within the code within the code. So it's a new code for interpreting and writing messages in DNA. In the remaining information in the watermarks contain the names of, I think it's 46 different authors and key contributors to getting the project to this stage. And we also built in a website address, so that if somebody decodes the code within the code within the code, they can send an email to that address. So it's clearly distinguishable from any other species, having 46 names in it, its own web address, and we added 3 quotations. Because with the first genome we were criticized for not trying to say something more profound than just signing the work. So we won't give the rest of the code, but we will give the 3 quotations. So the first is to live, to err, to fall, to triumph, and to recreate life out of life. It's a James Joyce quote. The second quotation is see things not as they are, but as they might be. So it's a quote from the American Prometheus book on Robert Oppenheimer. And the last one is a Richard Feynman quote, what I cannot build, I cannot understand. So with that, I would like to open it first to the floor for questions. Yes, in the back.
Could you explain in layman's terms how significant a breakthrough this is, please?
Can we explain how significant this is? I'm not sure we're the ones that should be explaining how significant it is. It's significant to us. Perhaps it's a giant philosophical change in how we view life. We actually view it as a baby step in terms of it's taken us 15 years to now to be able to do the experiment we wanted to do 15 years ago on understanding life at its basic level. But we actually believe this is going to be a very powerful set of tools. And we're already starting in numerous avenues to use this tool. We have at the Institute ongoing funding now from NIH in a program with Novartis to try and use these new synthetic DNA tools to perhaps make the flu vaccine that you might get next year. Because instead of taking weeks to months to make these, Dan's team can now make these in less than 24 hours because we think these tools can affect vaccines to diseases that haven't been possible to date, things where the viruses rapidly evolve, such with rhinovirus. Wouldn't it be nice to have something that actually blocked common colds? Or more importantly, HIV, where the virus evolves so quickly, the vaccines that are made today can't keep up with those evolutionary changes. Also at Synthetic Genomics, we've been working on major environmental issues. For oil, we have a program with ExxonMobil to try and develop new strains of algae that can efficiently capture carbon dioxide from the atmosphere or from concentrated sources, make new hydrocarbons that can go into their refineries to make normal gasoline and diesel fuel out of CO2. Those are just a couple of the approaches and directions that we're taking.